The diagram shows two circles, C1 and C2, of equal radius. C1 has center 0, 0, and it cuts the x-axis at 5, 0. Find the equation of C1. The point with coordinates 5, 0 is a point on the x-axis. You see the y value of the point is 0. So the circle cuts the x-axis at plus 5. It also cuts it at minus 5, of course, because the center is 0, 0. Center is equidistant from these 2 points. It cuts the y-axis at plus 5, and it cuts it also at minus 5. So the center is 0, 0. The center is labeled HK, H comma K. The radius of the circle is 5. How do we know that? Well, the distance of the center to the point with coordinates 5, 0 is obviously 5. So this is the radius. So the radius is called r. The equation of any circle is given by this formula here. X minus h all squared plus y minus k all squared equals r squared. You can just look this formula up. If we put in 0 for h, 0 for k, and 5 for r, we get x minus 0 squared. Well, that's just x squared, plus y minus 0 squared, that's just y squared, equals 5 squared, which is 25. In part B, we want to show that the point minus 3, 4 is on this circle. This is C1. So, if a point is on a circle, it must satisfy the equation of the circle. So the equation of the circle is x squared plus y squared equals 25. What we do is we plug minus 3 in for x, then we plug 4 in for y. We work this out. If we get the right hand side, which is 25, then we know that the point minus 3, 4 satisfies this equation, which means that the point minus 3, 4 is on this circle, x squared plus y squared equals 25. Well, minus 3 squared is plus 9. 4 squared is plus 16. 9 plus 16 is indeed 25. Minus 3, 4 is called P. This point here is shown on the diagram. The two circles touch at the point P. Well, we see that on the diagram. P is the point with coordinates minus 3, 4. P is on the line joining the two centers. Well, that's always true actually. If two circles touch at one point, then that point is on the line joining the centers of the two touching circles. So, you know, we don't really need to see that statement, but it happens to be true in general. We want to find the equation of C2. Now we're given that the radii of both circles are equal. So the radius of this circle is 5, so the distance from the center to the point P is 5. That means the distance of the point P to the center of circle C2 is also 5. Remember, we need two things for the equation of a circle. We need the center and the radius. Well, we know what the radius is. It's 5. But what's the center of C2? Well, we see that the center of C2 is the image of the center of C1, that's 0, 0, under central symmetry in the point P. Now, we can just work that out by considering two congruent triangles. These two right-angled congruent triangles. The distance from here to here is 3, because the x-coordinate of point P is minus 3. The distance from here to here is 4, because the y-coordinate of point P is 4. So we're just considering distances here. So it must be the same for this triangle here. This distance must be 3, same as this, and the vertical distance here must be 4. So to get the coordinates of this point, you can see what you have to do. We have to subtract 3, because we're going to the left, to get the x value of this point. So we see that 0 minus 3 is minus 3. Minus 3 minus 3 is minus 6. You'll see this if you draw a diagram. If you plot the points 0, 0 and minus 3, 4 on a coordinate surface you can just count the squares. It's easy to work out. The vertical distance between 0, 0 and the point P is 4. See, we add 4 onto the y value of the centre. 4 plus 0 gives us 4. So we add another 4 onto this. 4 plus 4 is 8. So that's quite easy to see if we draw it out. So the centre has coordinates minus 6, 8. Centre is referred to as HK. The radius is referred to as R. So the equation of a circle centre HK and radius R is x minus h all squared plus y minus k all squared equals R squared. You can look that up and plug in for h and k. We plug minus 6 in for h to get x minus minus 6 or x plus 6 squared. Then we plug 8 in for k, so here we get y minus 8 squared. We plug 5 in for r. 5 squared is 25. You can leave it like this. So this here is the equation of the circle. As an aside, I'll just do a check. You don't have to do this, of course. Well, I'll just check that the point minus 3, 4 is on the circle C2. If minus 3, 4 is on this circle, it should satisfy the equation of this circle. So if we plug minus 3 in for x and plus 4 in for y and work out all the left hand side, we should get 25. Let's just see that. So on the left hand side we have minus 3 plus 6 squared plus y is going to be 4 minus 8 squared. So if we work out all of this, we should get 25. Minus 3 plus 6 is 3. 4 minus 8 is minus 4. Minus 4 squared is plus 16. So we have 9 plus 16 is 25. We do only get the right hand side. Anyway, that's just on the side. You don't have to do that. Any point on the circle C2 should satisfy the equation of the circle. In part D, we want to find the equation of the common tangent at the point P. The tangent to the circle C1 at the point P is a line that touches circle C1 just at this one point P. And it's also the tangent to the circle C2 at P, because P is also a point on the second circle. And the second circle only touches C1 at one point. So this line is a common tangent. It's common to both circles. To get the equation of a line, we need the slope of the line and a point on the line. Well, we have a point on the line. It's the point P. It has coordinates minus 3, 4. How do we get the slope of this tangent? Well, we use the fact that the line drawn from the center of C1 to the point P, this line here OP, if I call the center O, the slope of OP, the line OP is perpendicular to the tangent at P. So that's a very important fact from geometry. So OP is perpendicular to the tangent at the point P. So if we can get the slope of OP, then we can get the slope of a line perpendicular to OP. So let's get the slope of the line joining O to P, this radius. Well, we just use the formula y2 minus y1 over x2 minus x1. You can call this point x2, y2 if you like, and this point x1, y1. So we have y2 minus y1, which is 4 minus 0 on top, over x2 minus x1, which is minus 3 minus 0 underneath. So that gives us plus 4 divided by minus 3, which is minus 4/3. So knowing the slope of OP, we can get the slope of the tangent. So the tangent is perpendicular to this line. So to get the slope of the tangent, we invert the slope of OP, change the sign. So minus 4/3 becomes plus 3/4. To get the equation of the tangent then, we look up a formula for the equation of a straight line. This tangent is a straight line after all. And m is the slope of the line, so m will be 3/4. x1, y1 is a point on the line, so x1, y1 is the point minus 3, 4. And the slope is called m in the formula for the equation of a line. So we plug everything into this. Of course, y and x remain as they are. Y and x will be the coordinates of any point on the line, any general point on the line. X1, Y1 is a given point on the line. So we have y minus y1 or y minus 4 equals m, which is 3/4, into x minus x1. That's x minus 3. That becomes x plus 3. Normally we get rid of fractions by multiplying both sides of this by 4. If we multiply the left hand side by 4, we get 4y minus 16. If we multiply the right hand side by 4, we get 4 times 3/4, which is 3. So we're left with 3 into x plus 3, which is 3x plus 9. We normally bring everything to one side, so we get 4y minus 3x. Minus 16 minus 9 is minus 25, and we have 0 on the right hand side. So this is the equation of the line, or of the common tangent. Just notice a few things here. The slope of OP is negative, as expected, because it's a line going in this direction. So it's minus 4/3. The slope of the tangent is positive, as expected. Tangent is going in this direction.